This topic's collision. Collision. So redistribution of the momentum, that is called collision. Any body redistribution of the momentum in particular interval of time, that is called collision. So redistribution of the momentum in any body particular interval of time, that is called collision. In collision, momentum conserved. In collision may or may not be a physical contact. Momentum conserved, energy, mechanical energy conserved, and kinetic energy may conserved, may not be conserved, may or may not be conserved. So momentum conserved, mechanical energy conserved, kinetic energy may or may not be conserved. That is called collisions. So types of collisions, that is in the direction of motion collision, two types. One is the head-on collision, one dimensional collision. Second, oblique collision. 2D or 3D. 2D or 3D. One dimensional collision and two dimensional collision. So one dimensional collision. So in one dimensional collision of the particles, so velocity same direction. Velocity do not change, the same direction velocity. That is called one dimensional collision. So oblique collision in different directions, before and after different directions. Oblique collision of the velocity different directions, before and after collision. Direction also different. Here same direction. Direction also same. Before and after direction also same. Velocity direction before and after same direction. Here velocity direction also different before and after collision. That is called oblique collision. Direction depend on two types of collisions, one dimensional collision and oblique collision. So energy conservation collisions, two types. One is the elastic collision, inelastic collision. Elastic collision and inelastic collision. In conservation of energy, in collisions, two types. That is one is the elastic collision. In elastic collision, momentum conserved, and kinetic energy also conserved. That type of collision is called elastic collision. So example, collision between the small particles, collision between the brains balls, collision between the alpha particle and the nucleus, collision between the alpha particle and nucleus. That is example of the elastic collision. So next, inelastic collision. Second, inelastic collision. So momentum conserved, and kinetic energy do not conserve. Momentum conserved, kinetic energy do not conserve. That type of collision is called inelastic collision. So example, collision between the two vehicles. Here sound and light energy, sound energy also produced. In elastic collision, sound energy, light energy do not produced. Less kinetic energy, sound energy, less sound energy, less light energy. Elastic collision. In inelastic collision, sound energy, light energy also more, and damage also more. In elastic collision, damage also more. Elastic collision, damage also very less. So another type of the collision, perfect inelastic collision. Perfect inertia collision. After collision, the particles embedded. The particles also complete embedded also same velocity, move the same velocity. That is called perfect inertia collision. After collision, the particles also complete embedded and single velocity, move the single velocity. That is called perfect inertia collision. Perfect inertia collision. Perfect inertia collision. Both are stick together. Both are stick together. Single velocity. Stick together. Embedded. Embedded both are embedded and single move the single velocity. That is called perfect inertia collision. Then M1, U1, M2, U2. Final velocity, single velocity. Both are same velocity. Move the same velocity. That is a perfect inertia collision. The bullet come into the brick or board. So embedded in the board, that is a single velocity. Example of the bullet entered into the board or wood. That example, perfect inertia collision. Perfect inertia collision. So here M1 is a mass, U1 velocity, M2 mass, U2 velocity. Both are collisions and different velocities. V1, M1, M2, V2. Find out the final velocities. So U1. Here conservation moment of M1, U1 plus M2, U2 equal to M1, V1 plus M2, V2. So M1 into U1 minus V1 equal to M2 into V2 minus U2. The first equation. The equation 1, M1 into U1 minus V1, M2 into V2 minus U2. Second, conservation of kinetic energy of M1 U1 square plus of M2 U2 square equal to of M1 V1 square plus of M2 V2 square. Both sides half of cancel. M1 V1 square minus V1 square, M2 V2 square minus U2 square. So this is second equation. So 1 by 2. The second equation is M1 into U1 square minus V1 square equal to M2 into V2 square minus U2 square. 1 by 2 or 2 by 1. M1 into here U1 minus V1, U1 plus V1 equal to M2 into V2 minus U2, V2 plus U2 by M1 into U1 minus V1, M2 into V2 minus U2. That cancel. That is a M to cancel. So here U1 plus V1 equal to V2 plus U2. First of all, find out the V1. V1 is equal to V2 plus U1 minus U2. This equation placed here. First equation. This is third equation. Third equation substitute in the first equation. That is equal to V1. Find out the V1 equations. M1 minus M2 by M1 plus M2 into U1 plus 2M2 by M1 plus M2 into U2. This final velocity V1. So V2 2M1 by M1 plus M2 into U1 plus m2 minus m1 by m1 plus m2 into u2. The final velocity of the collisions. Final velocity of the collisions. Here 4 cases there. What is the final velocity? What is the equation? v1 equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So v2 is equal to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. So final velocity of the collisions, one-dimensional collisions.